Hello everyone, and welcome to another Science Tutor video. I'm your tutor Nathan, and we are going to continue the topic straight line motion. So in a previous video, we discussed the two physical concepts, distance and displacement. And we said that distance is the separation between 2 points, usually along a certain path, and is a scalar quantity. In other words, it has no direction associated with it. We also mentioned that displacement is a distance measured in a particular direction, or the net separation between 2 points in a particular direction. Right? Because displacement has an associated direction, it is a vector. Right? So distance is a scalar quantity, displacement is a vector. And if I give you a quick example, if an object starts off at an initial location and moves, say, 2 meters along a curved path like so, then moves another 2 meters along a curved path like so, and then moves 3 meters back to the starting location, they end up where they started, and the distance, which in this case would be equal to 2 meters plus 2 meter plus 3 meters, which equals 7 meters, right? While the displacement is the net distance moved in a particular direction, and in this case is equal to 0 meters, because the starting location is equal to 0 meters, because the starting location, or a starting point, is equal to the ending point. Alright? So because of that, the net distance moved in a particular direction, or the net displacement of the object, is 0. Alright? So please take careful note of that. If the starting point of an object is equal to the ending point after it's moved along a particular path, the displacement is 0. So we can move on to two concepts that are derived or explained from distance and displacement. And as we move on, I want you, if you haven't already, to make sure that you're clear on the difference between distance and displacement. One is a vector, one is a scalar quantity. Make sure you know why one is a vector and why the other one is a scalar. Alright, so if you need to make notes on that, underline that in your book. You can go ahead and do that now. Alright, so the concepts we're going to look at now are speed and velocity. Alright, so right on the distance, the first one is derived from the distance. We have speed. Now, most of you have an idea what speed is already. It's an idea of how fast something is moving. The technical definition that speed is equal to the rate of change of distance. Right? And in physics, whenever you see a rate of change of a physical quantity, it's equal to the physical quantity, or the change in the physical quantity, divided by the time it took to make that change. So speed is just really distance covered divided by time taken. Alright? Now, distance is a scalar quantity, right? And we know this. Speed is derived, and when we use the word derive, we just mean it's obtained by considering distance and time, which are also both scalar quantities. So what kind of quantity do you think speed would be? You can guess, but in physics you don't need to guess. The answer is that speed is also a scalar. Alright, so the speed of an object has no particular associated direction. However, when you talk about velocity, here's where direction becomes important. Velocity equals the rate of change of displacement. Alright? It has the symbol V, and V is equal to displacement, which has the symbol S, or sometimes X, divided by T. Alright? Which is equal to displacement divided by time. Alright? Now, displacement is derived from time, which is a scalar, and displacement, which is a vector. So displacement, which gives rise to velocity, is a vector, and that means that velocity is also a vector. Right? So a velocity has an associated direction, and velocity is a vector quantity. Alright? So speed is a scalar, velocity is a vector. Right? Please take careful note of that fact. Now, even though those two quantities are different in their nature, they're both calculated in the same way. So you have a distance which has units of meters divided by a time which has units of seconds. So the units of distance divided by time, or the units of speed, are meter per second. In the same way, if you divide a displacement which has units of meters by the units of time, which are seconds, then the unit you get is meter per second. So even though speed and velocity are different, in other words, one of them is a scalar, one of them is a vector, they both have the same units. So it's important for you to be clear on the distinction why one of them is a vector and one of them is a scalar. Right? One of them is derived from displacement, which is a vector, and since the displacement has a particular direction, the velocity is also in the same direction. Right? So please take careful note of that fact. So let me give you an example. Right? If you need to take a break, get up, drink some water, and come back to your computer screen. Right. In the Caribbean, we're usually big on athletics and sports and so on. So I'm going to use a sporting example. If a 100-meter sprinter covers that distance in 10.5 seconds, what is his speed? Alright? So a 100-meter sprinter covers 100 meters in 10.5 seconds. What is his speed? Now, of course, the first thing that might jump out to you from that question is that 10.5 seconds is a lot of time, because we have some really fast people in athletics nowadays. But that aside, there's some other things I want you to circle in this question and pay careful note to. The first thing is they give you the distance that he covers, 100 meters. They also give you the time taken, just 10.5 seconds. Right? So in starting a question like this, make a note of the distance and make a note of the time, because even in the case where you might not remember the exact formula, if you can identify what you've been given, it gives you a head start, so you at least have an idea what you're supposed to be working out. So now the distance is 100 meters, time is 10.5 seconds. And the formula we have for speed is that speed is equal to distance covered divided by time taken. Right? So the sprinter speed is equal to 100 meters divided by 10.5 seconds. Alright. So the speed is equal to 100 meters divided by 10.5 seconds, which gives you a speed of 9.52 meters per second. Alright? Simple. Suppose they had asked you, what is his velocity? Alright? Remember, both distance and displacement are, in a way, distances. So the formula itself is not going to change. Speed and velocity are equal to the particular distance you're covering divided by the time taken. Remember though that velocity is the rate of change of displacement, which is the rate at which you cover a distance in a particular direction. So you need to find out, first of all, what is the sprinter's displacement to calculate his velocity. And in this case, his displacement is simple. It's along the track. You start off at the beginning of the track and travel in a straight line, hopefully, straight down the track. So his displacement is equal to 100 meters along track. Remember that this is a vector quantity. Direction is important. Time taken is still 10.5 seconds. So the velocity now, v, is equal to 100 meters divided by 10.5 seconds, which is still 9.52 meters per second, but now it's 9.52 meters per second along the track. Why is this important? Because speed is a scalar, but velocity, which we just calculated, is a vector quantity. So this last part, the direction along which the sprinter was traveling, is very important. Right? There's a key thing for you to note. Displacement and velocity share a common direction. Alright? Now what does this mean? Alright? What does this mean? It simply means this. If you have a displacement to the right, in many cases, the velocity will be along the same line. So if S or X, because both of these symbols are used, is to the right, then V is also to the right. If your displacement is upwards, then your velocity will also be upwards in most cases. Right? And that's something important for you to remember, because in the example above, you weren't explicitly told in which direction the sprinter is running. You kind of have to use common sense and know he's running down the track. And so his displacement and velocity are both going to be angled down the course of the track. Yeah? So review this example, make sure you understand it, and make sure that you're comfortable with the concepts of distance and displacement and speed and velocity. Alright, just to review, today you learned that speed is equal to distance divided by time, and that velocity is equal to displacement divided by time. Alright, so write these two equations down Make sure you understand them. Make sure you know how to use them. Alright, keep studying. Make sure to share this video if you like it. You can like it on Facebook. Remember, studying is important. And make sure to come back for the next Science Tutor video. Alright, thank you for watching.